overview of Chapter 9, be able to do binomial expansions. Just a quick reminder, there's two methods. The fallback one is to do descending x, so if it's x plus 3 to the 7th, it's x to the 7th, x to the 6th, x to the 5, x to the 4, 3, x to the 2, x to the 1, x to the 0. For the 3, it's 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4, 3 to the 5, 3 to the 6, 3 to the 7. Notice that all the powers add up to 7. Then we have the coefficients. Now the coefficients, you can use Pascal's triangle. Or you could do 7 choose 0, 7 choose 1, 7 choose 2, 7 choose 3, 7 choose 4, 7 choose 5, 7 choose 6, and 7 choose 7. You can use your calculator to figure those out, or you could do that wonderful Pascal's triangle, but this way you have to go all the way to 7, 15, 20, 25, 6, 1, oh my word, 7, 1, 7, 21, 35, 35, 21, 7, 1. So this is going to be 1 x to the 7th plus 7 times 3, which is 21, x to the 6th. 7 choose 2. Well, that was 21. So that'll be 21 times 9, whatever that is, x to the 5th. The next one's 35. 35 times 27, x to the 4th. Another 35 times 81, x to the 3rd. And then it's 21 again times, I don't know, well, 81 times 3 is 243, x, and then the last one is just 1, and whatever 243 times 3 is, 9, 12, 729. And they wanted the x to the 4th term. So the x to the 4th term is whatever 35 times 27 is. That's going to be the coefficient for the x to the 4th. Now we could also do this without all of that hassle. We don't have to do it that way. We could say n is the power, which is 7. Your first part of the binomial is x, right? Your second part of the binomial is 3. The x to the 4th, well, we have x to the 7, x to the 6, x to the 5, x to the 4. Well, that's going to be the 4th term. So the term is 4, and the j value in the formula is going to be 4 minus 1, which is 3. So using the formula, which is n choose j, a to the n minus j times b to the j, and so that's going to be 7 choose 3. A is your x to the 7 minus 3, and you'll have 3 to the 3rd. Well, 7 choose 3 is 35. X to the 4th times 27. Well, there you go. 35 times 27, x to the 4th. So the formula works as well. Very good. All right. Sequence, arithmetic sequence, arithmetic series. So sequence is a list. Series is a sum. Find the 20th term and the sum. So the first term is a. The number of terms is 20, and the common difference appears to be -4. Okay, so then if we want to know the 20th term, you go a plus n minus 1 times d. If you want to know the sum of the 20 terms, you go n over 2 times 2a plus n minus 1 times d. And just plug those values in and get your answers. That's arithmetic. Geometric has a common ratio, right? And so common ratio, you need to find that ratio. But let's see about these guys here. See if these will give you an infinite series. So 1 plus 3 plus 5, I'm adding 2 each time. This is not geometric, so there's no sum. This one, if I do my ratio, it's going to be times negative 1/4, it looks like. That is geometric, and the ratio is less than 1, perfect, greater than negative 1. This one will work out fine, sum to infinity, a over 1 minus r. A is the first term, 2, r is negative 1/4. So it's 2 over 5/4, which is 8/5. That's the sum as this guy goes to infinity, not this. And then sigma notation, talked about that. With sigma notation, you have your starting point, you have your ending point, you have your formula. Now this one's kind of nice because what we can do is we can, and we usually use I or J or K. I'm going to call this one K just to make it a little unique. Put numbers in. So put a 1 in. So this is going to be 3 times 5/9 or 5/3. The next one is going to be 3 times 25/81s, and then it's going to be 3 times 125 over 243, and keep going here. Looks like the first term is 5/3. Looks like the ratio is 5/9. It's geometric, and the ratio less than 1, so you can find the sum to infinity, a over 1 minus r. And that's going to be 5/3 over 9 minus 5, 4/9. 15/4, I think, is that sum. All right, so there's your sigma notation. Couple comments about sigma. Make sure that if you're looking at geometric, it's r to the n. If you're looking at arithmetic, then it's going to be difference times n in your formula. And then we've talked about proving by math induction. You have you're going to have your 3 steps. Step 1, 2, and 3. You're going to do n equal to 1, n equal to k, n equal to k plus 1. And I'll let you tackle this one. I think we did one like it already. All right, here's some practice. I have a sequence. You come up with the sigma. You come up with the sum to infinity if it has one, and the 10th term. Do the same with this one. Is it arithmetic or geometric? Make that sigma notation. Sum. Does it have a sum to infinity? Can you find that A10? I've got some binomial expansions that you can do for practice. Some review problems. This 1, A through D, 2 and 3, these have answers at the end that you can check. So that's my review for Chapter 9. It's a big one, and takes lots of practice. Ask me questions if you have them. Congratulations on finishing semester 1. See you at testing time, and I'll need all 3 labs before you take that last test.